Let's continue with example 2. It says, suppose in a normal distribution, the mean is 75 and the standard deviation is 10. Find the proportion of area A to the left of a data value of 70. So let's just start with part A. And even before I go to the question, I want you to get in the habit of doing this. Always write down anything you know about the problem first. So what I mean is, it says, suppose in a normal distribution. So right away, as soon as I see normal distribution, I'm going to sketch a picture, right? I'm going to sketch a picture of a normal distribution. So we'll do A right here. Here's my normal distribution, bell-shaped curve. That's it, right? Now, I'm giving you the mean of the distribution. It's equal to 75. And the mean always goes in the center of a normal or a bell-shaped distribution. And a standard deviation is equal to 10. Remember, that measures the spread. So that's not a label on the table like the center. This just gives us the average deviation from the center. Now, let's figure out what we're looking for. We want to find the proportion of area to the left of a data value of 70. Now, I want to say another way that we could think of this. Finding a proportion of area, remember, that's just equal to probability. Remember, area under the curve is just equal to probability. Let's go back up for a minute. So remember in this first example we did a couple of lectures ago, area of a rectangle is equal to the probability, or the area under the curve is equal to probability. So another way that I could write this, because proportion of area is a probability. So we could say, what is the probability? So underneath A, I'm just going to write this in math notation rather than English, where it says to the left of a data value of 70. Another way to write this is, what is the probability that our data value is going to be less than 70? Because to the left of a data value means less than to the left. And a data value, we use X, right? X is just a raw score. So another way to write this using math notation is, what is the probability that the score or the data value is less than 70? That's what we're trying to find. That represents the proportion of area to the left of 70. Let's put that on the picture. Where is that proportion of area? Well, 75 is the mean. That's in the middle, right? So where's a data value of 70 going to go? Label your picture. So X equals 70 is going to go to the left because 70 is less than 75. Now shade the appropriate area. We want the area to the left. So I'm going to shade the area to the left. Now we're ready to get our answer, right? For this first part, I'm going to show you 2 ways to do it. I've already taught you both ways. Going forward, it's going to be a matter of preference. Like I keep reiterating, I'm going to use the calculator going forward, but let me do one more where we use both the table and the calculator. So one way to get the area under the normal curve is to use the normal table. So remember the normal table. Here's my normal table. But in order to use the normal table, you need a z-score. You have to look up a z-score. I don't have a z-score here. I'm using a raw score, right? That X equals 70 is a raw score. So what we need to do is we need to convert it to a z-score. And remember, my z-score formula is equal to data value minus the mean over the standard deviation, or X minus mu over sigma. So let's convert to a z-score. So I'm going to take 70 minus the mean, which is 75. And I'm going to divide by 1 standard deviation, which is 10. And we're going to get negative 0.5. So if you do 70 minus 75 and divide by 10, we get negative 0.5. So this raw score of 70 corresponds to a z-score of negative 0.5. So now let's go to the normal table. We should be on the negative table, right? And let's look up negative 0.50. So here's negative, let me draw in red so we could see this better. So here is negative 0.5, and then we have a 0 in the hundredth spot. And my area to the left, remember the table only gives us the area to the left. So that's going to be 0.3085. So this area here is 0.3085. And that represents the proportion of area to the left of 70, or the probability that x is less than 70. So we did a table lookup, but like I said, in order to use the table, you have to convert raw scores to z-scores. Now, the other way I could do this is using the calculator, and we're going to get the same answer. So now let me show you how to do this using the calculator. So we need lower, upper, mean, standard deviation, right? Anytime you want to use the calculator. So let me erase my z-score work. Now lower, we're coming in from the left, right? So my lower is going to be negative infinity. My upper, for my upper, I could do this two ways. I could either use the raw score of 70, or I could do the z-score of negative 0.5. We just have to use the appropriate mean and standard deviation. So let's do this both ways. So let's go to the calculator, pull up normal CDF. Either way, the left is negative E99. But now one option for the upper is to use the raw score. We could totally use the raw score if we want to, which was 70. But now when I go type in the mean and the standard deviation, I can't use 0 and 1 because 0 and 1 are the mean and standard deviation for z-scores. 70 is a raw score, so we have to use the mean and the standard deviation of the distribution. The mean is 75 and the standard deviation is 10. So that's what I'm going to type in since I'm using raw scores. And what the calculator is going to do is the calculator is going to convert to a z-score, do a table lookup, and give us the area. And it does it so quick, you don't even see it. And there's my 0.3085, right? The first 4 decimal places is the same thing we got from the table, 0.3085. Now, the other way we could do this is by using the z-score. We could use the upper value as negative 0.5. So let's do that, and you'll see we're going to get the same answer. So let's pull up normal CDF. My lower is still negative infinity, but now let's use for the upper negative 0.5. We'll use the z-score instead of the raw score. But how are you going to change the mean and the standard deviation? Think about it. What are you going to put for mu? It's going to be 0, right? Because 0 is the mean of all the z-scores, and we're using z-scores. And 1 is the standard deviation of all the z-scores. So we're going to use 0 and 1 for the mean and the standard deviation. And we're going to get 0.3085. So there's a few different ways you could do this. It's a matter of what you're comfortable with, and that's the way I want you to do it. So let's look at part B. So going forward now, I'm just going to use the calculator. So part B, we want to know what's the proportion of area to the right of a data value of 58. So what I'm saying is, what is the probability that x is greater than 58? Because that's the area to the right. So let's make a picture of that. So the mean is 75. And a 58 is less than 75, right? So I'm going to put x equals 58 to the left, because on a number line, 58 is to the left of 75. but we want to shade the area to the right or greater than. So this is the area that I want to find. And let's use the calculator. So now I'm going to go straight to the calculator. So my lower is going to be 58 because that's where the shading begins. You can convert it to a z-score if you want. If you want to use z-scores, that's fine. But why do that if you don't have to, right? So I'm not going to do extra work than I have to. Let's use the raw score. So my lower bound on the shaded region is 58, and we're shading all the way to the right, which is going to be positive infinity, or E99. And then the mean of this distribution is 75, and a standard deviation is 10. So we'll go to the calculator. We're going to do normal CDF. The lower bound is 58. The upper bound is E99. The mean of this distribution is 75, and the standard deviation is 10. And we get 0.9554 to 4 places. So that's the proportion of shaded area, 0.9554. So that was part B. And now let's do C. So C, we want to find the probability, and I'll squeeze that in down here because there's not a lot of room up there. So C, we want to find the proportion of area now between a 60 and a 78. So we want the probability that, or the proportion of area such that X is between 60 and 78. So that's how we use between in math. We have to write a compound inequality where X is in the middle. So let's sketch our picture. Normal curve, mu equals 75 in the middle. And 60 is less than 75, so I'm going to put X equals 60 to the left. And then 78 is bigger than 75, so I'm going to put that to the right of 75. And we're shading between. So this is the proportion of area that we're interested in. So my lower bound is X equals 60. That's where the shading begins from the left. And it ends on the right at X equals 78. So that's going to be the upper. And the mean is 75, and the standard deviation is 10. So let's go to the calculator. We're going to do normal CDF. The lower is 60. The upper is 78. The mean is 75, and the standard deviation is 10. And we get to 4 places, 0.5511. So the shaded area between 60 and 78 is 0.5511. So that wraps up example 2. In the next lesson, we'll start some application questions. And when I say application questions, I mean word problems. So we're still going to be using the same concept of a normal bell-shaped curve, and we want to find a proportion of area. But now we're going to start to look at word problems. So we'll start example 3 in the next lesson.